let's start with reductive amination. First, the general reaction. The general reaction here is R equals H, alkyl, or aryl. Okay, and that means we have aldehydes and ketones. We can treat those with an amine source, and this can be NH3, primary or secondary amines. They have to have at least one hydrogen. Now, depending upon the amine, the most commonly used, the best method is sodium triacetoxy borohydride. So sodium HB with 3 acetates. Attached to it. This is typically done in THF and with a little acetic acid. You want the pH to be approximately 4 to 5. This is important that you control the pH here. This works well for primary and secondary amines. It's okay for ammonia. Typically for ammonia, one's going to use nickel and hydrogen or some other palladium and hydrogen to do the reductive amination. But if you have an alkyl group on there, sodium triacetoxy borohydride is just a super reagent. It's not toxic, it is efficient, and what you produce here, so there's our R group, we'll call that one R prime, it's attached. We get reduction. So we have added hydrogen across what was the carbon-oxygen double bond. Now, if you're thinking about the chemistries we've been learning lately, you probably already have an idea of what the mechanism is going to be. But let's look at we could take a carbonyl compound. Having an ester in there isn't going to hurt us. We can, for instance, add cyclohexyl amine with our sodium triacetoxy borohydride. So at these pHs, it will not reduce the ester, and it won't reduce the ketone either. Again, pH about 4 to 5. You get the pH below 3, sodium triacetoxy borohydride will actually start to reduce the ketone. So this is a very convenient and useful reaction. As you might imagine, and again, I'm not going to push the arrows that we've already pushed, in the acidic conditions we form, and I'm just going to call that R prime. I'll use CY to illustrate for cyclohexyl. It forms the imine, which of course is still pretty basic, and so it will be protonated to make the iminium ion, and that's now a much better electrophile. And so the boron species, I'm just going to illustrate it with the brackets there, delivers hydride to this, and that's an irreversible reaction. CY for cyclohexyl again, and we reduce that species. So that's reductive amination.